Welcome to this video on electricity, where we will explore how circuits work and the key components that make them functional. So, what is electricity? At its core, electricity is the flow of electric charge, typically electrons, moving through a conductor, like a wire. It is a fundamental form of energy that powers our daily lives. Electricity can be generated in several ways, by converting different forms of energy into electrical energy. Sources include wind, solar, falling water, natural gas, and coal. Once generated, it travels through power lines to reach our homes, schools, and workplaces.
We use electricity for countless tasks every day, from cooking and lighting our homes to transportation, communication, and entertainment. Ultimately, electricity makes our work easier, saves time, and significantly improves our quality of life.
An electric cell is another portable source of energy. If you look closely, you will see a positive terminal, indicated by a metal cap, and a negative terminal, which is a flat metal disc. All electric cells must have these two terminals to function. A battery is created when we connect two or more electric cells together. By combining them, we create a more powerful energy source for our devices. How are these cells connected? To form a battery, the positive terminal of one cell must be connected to the negative terminal of the next cell in the series. Why use a battery instead of a single cell? A battery composed of multiple cells provides more energy and allows electronic devices to operate for a longer period of time. Next, let's look at an incandescent lamp. It consists of a glass bulb and a thin wire inside called a filament, which is essential for producing light. How does this lamp work? When electric current flows through the filament, the wire becomes extremely hot, causing it to glow and emit light. The lamp itself has two distinct terminals, the metal case and the metal tip at the base. Both are necessary to complete the electrical connection. Inside the bulb, the filament is connected between these two terminals. This internal wiring ensures that electricity can pass through the filament when the lamp is powered. LED stands for light-emitting diode. These are efficient electronic devices that emit light when current passes through them. Because they use significantly less energy, they are found in chargers, routers, and many other modern devices. Finally, remember that LEDs require a correct connection to function. The longer leg must be connected to the positive terminal and the shorter leg to the negative terminal. Otherwise, the LED will not light up. Let's compare the traditional incandescent lamp with the LED. While the incandescent lamp uses a heated filament to produce light, the LED relies on a diode structure, which lacks a filament entirely. The terminal design differs as well. An incandescent lamp is omnidirectional, meaning current can flow through it in either direction. In contrast, an LED is one way, requiring current to flow in a specific direction, from positive to negative. Now, let's look at the switch. A switch is a simple device that makes or breaks the electrical connection in a circuit. When the switch is in the off or open position, no current flows. When moved to the on or closed position, the connection is complete, allowing current to flow. Consider a torchlight as a portable source of electricity. When you slide the switch, you complete the circuit, allowing electricity to flow and the bulb to glow. Sliding it back opens the circuit, stopping the flow of electricity. Electrical circuits are often represented by standardized symbols. This helps engineers and students easily draw and interpret the design of any circuit, from a simple cell and bulb to complex electronic systems. Here are common electrical components and their corresponding symbols: the electric cell, a battery of multiple cells, the electric lamp, the LED, the switch in both positions, and the basic connecting wire. Using these symbols, we can map out circuits. When using an LED, a complete circuit with the switch in the on position allows current to flow and the LED to glow. An off switch leaves the circuit incomplete, so the LED remains dark. Similarly, Circuit diagrams for an incandescent bulb help us understand the flow of energy. A closed circuit allows current to power the bulb, while an open circuit results in no current flow and no light. Good conductors, such as copper and aluminum, allow electricity to flow easily. Poor conductors or insulators, such as wood, rubber, and plastic, resist the flow of electricity and help keep us safe. Conductors carry electricity from one place to another, while insulators act like safety shields that prevent electric shocks. Both are essential for the safe use of electricity in our daily lives. There are two types of electricity, DC and AC. DC, or direct current, flows in one direction and is used in batteries, remote controls, and toys. AC, or alternating current, changes direction repeatedly and is the type of electricity supplied to our homes through wall sockets. Electric shocks, short circuits, and fires are real risks. Respect electricity. It's a friend when used wisely, but dangerous when ignored. Never touch electrical appliances with wet hands. Do not insert objects into electrical sockets. Stay away from damaged wires and always ask an adult for help when dealing with electrical equipment. Safety should always come first. Remember, being cautious is possible only when we have knowledge of the things around us. Your zeal to learn is the best way to navigate dangers and the foundation of all great discovery and invention.